This is project 2, video number 1, the one where we do the pencil and paper part. So we got a circuit, looks like this. Call it it's a parallel combination of two resistors. R2 and R3 in series with R1 and in series with a seed of EMF. V equals 28 volts. We're given R1 is 44 ohms. R2 is 22 ohms. And R3 varies from 0 to 200 ohms, and we're supposed to get the power across R2, or the power dissipated in R2 as a function of the value of R3. So let's use the method of ever simpler circuits. We'll combine these two resistors that are in parallel to form a single effective resistor, I'll call it RP. Yeah, let's call it R23. 1 over R2 plus 1 over R3. Then we'll have our seed of EMF. And a resistor R1. And we'll call the current here, that's the current through the seed of EMF, we'll call it I. We'll call it I up here as well. And then we'll create the next simpler circuit, which would be those two resistors in series, form a single effective resistance, and just call it R total. This is our V, 28 volts. This is our V. Here's our I in this circuit. V equals 28 volts. Our R total is R1 plus R23. Let's start numbering these equations. I'll call this equation 1. This is equation 2. And tell the reader how I'm proceeding here. That was the first equation I wrote down. And this is the second one. And then let's analyze this circuit. To get the current. So let's see. We use V is equal to IR. Written specifically for this resistor, R total is its resistance, I is the current through it, and V, the total V in the circuit, is the voltage across it, because the seed of EMF is hooked right across that resistor. So I can call this equation 3, and that was my next stop in my journey. Going from here. I was up here before, so we'll go from there to there, and then I want to use this in the next more complicated circuit. So let's see if we can move up a little bit. So I guess I haven't. That's not equation 3 yet. Let's express that. I want to get I. I was my plan, my goal. So I is V over R total. There's my equation 3. This was my next, the next part of my calculations coming from up here. So it's showing that in red. Alright. And then now I got the I. That's what I want to take up to this next circuit. So up here I know what I is at this stage, and so I can get the voltage across R23, because this current is the current through R23. The current I just found is the current through R23. So from that I can write, I want to put it beside this circuit because that's what I'm analyzing right now. V23 is equal to I times R23. Alrighty. I'm going to call that, we're up to equation 4, and just tell the reader where we came down from down here. So this was the next step in my calculation, was to go up to there, and then I'm going to work that up to the next circuit, and in the next circuit I see that the voltage across R23 is the voltage between these 2 points. That's these 2 points right up here. So it's the voltage between this conductor and that conductor. In other words, V23 is V2. So we'll write that down as a complete step. I might need some room, so alright, V2 is equal to V23. So I'm working my way up to the next circuit. So, and then once I got V2 and R2, I should be able to calculate the power. From your formula sheet, the formula for power is P is equal to IV. So for this resistor, that would be I2. Well, that hasn't been defined, so let's define an I2. So the current through R2 times the voltage across R2, which I've indicated it but I haven't defined it. I better define these voltages in my diagram, so let's put a plus and a minus here. Call that V23, and see if there's anything else I haven't defined down here. I think we're okay. So times V2, that's where I was, right there. Okay, so that's the power dissipated in resistor R2. I should probably call it P2, which is what we want. Now, the thing is, it's got an I2 in there. I could solve for I2, but I think, let's go ahead and do that. So, I2, well, from V2 is equal to I2 R2, I have I2 is equal to V2 over R2. So now I have a value for I2. That's my, let's see what we're up to, equation 5 here. So this will be equation 6. I'm going to check to make sure that we haven't missed any. I'm working my way up from here to there. That's the next step. And then this is the last step. And I can call that equation 7. Alright, let's see if I miss numbering any of these equations. So we started with the parallel combo, equation 1, 2, 3, 4, 5, 6, and 7. Alright, I think let's write out an outline of the code. So step 1, initialize some variables, namely V is equal to 28 volts. R1 is equal to 44 ohms. R2 is equal to 22 ohms, and I think that's it. And 2, we'll do a linspace to fill up R3, so R3 is linspace, and it's supposed to go from 0 to 200. I'll try 101 steps. So it'll do the 0 and then 2, 4, 6, 8, etc. up to 200. And then 3, I'm going to try to evaluate equations 1 through 7. Being careful that there will be a lot of arrays in there. And array P2. I think that's what I call it, the power across resistor R2, because I want the power dissipated in resistor R2. So that is the one. The power dissipated in R2 is what I should call it. And there it is. P2 is the name I gave it, and it was equation 7. And then 4, plot. I'm plotting P2 versus R3. R3 was the original array that we created, with R3 going from 0 to 200 ohms. Alright, that should do it for the pencil and paper part. Beware, if I find mistakes as I do the coding, I'll make adjustments to that. So make sure you watch all 3 videos before you turn on the pencil and paper part, if you want to make sure that you get it right.